So today we are going to take an important topic of class 9th, which is work and energy. Okay. So basically, in this chapter, we will more focus on work and the form of energies. Okay. So basically, if we say about work is basically mathematically, it is the product of force and displacement. F is denoted by force. This is force, and S, which is displacement. I will write this like S is displacement. It is the denoted symbol. You can also write D also. Okay, it's up to you. But generally, S is denoted in general standard books. So S is displacement, and F is force. So this is the mathematical formula basically. Now, how we will feel that? Now let's take a feel of this, that how work implies on the bodies and how it actually happens. So we will take the free body diagram of some in the form of some examples. So if we take a block like this is the block which is on a floor like this, and we applied some force on the block like this in this direction. This is the direction of force. Okay, and the body is moving like this. This is the component, or we can say the direction of motion. This is the block. Okay, so we will see that force is in this direction, S is in this direction, and this is the angle between the force vector and S vector. Okay, because force is a vector quantity and displacement is also a vector quantity, and you also know that the vector quantities are those quantities which have magnitude as well as direction. Vector quantities having magnitude as well as and direction both. Okay, so if we will resolve this, we will get work is basically Fs cos theta. This is the resolved. When we resolve the component, we will get this. So theta plays a vital role in deciding the work done. Okay, so this is the generalized equation. Okay, you should know this. We will use this in numericals also, so you should know this also. Okay, now take in some other example. Suppose the block is like this. This is the block. Okay, and I'm applying force like this. I'm applying force like this. Okay, and displacement is in this direction. Suppose let's take the displacement in this direction. Okay, so in this case, what will be the work done? Suppose this is the question, what will be the work done? I just giving this example to make you feel what's the significance of the angle component. Okay, so you can see the component F is in the downward direction and displacement is in the right direction. Okay, so the what will be the angle between the force vector and displacement vector? Force is in this direction and S is in this direction. Angle is basically 90 degree. If theta is 90, so you can say the component of force and displacement will give you zero value, because work is Fs cos of theta, and theta is 90 and cos 90, you know that it is zero basically. So work done is zero in this case. Okay, this is the question. This is the generalized case basically. If I would say that I'm applying the force in the on the block, if I'm applying the force constantly on a block and there is no such displacement seen in the block, we can say that in that case also work is basically zero. If there is no displacement, if there is no displacement. Okay. Now, work can be negative also. Work can be negative. Work can be negative. If the angle between force vector and displacement vector is 180-degree. If it's like this type of case in which force is in this direction and displacement is in this direction. So angle will be 180, which will give you negative value. Cos 180 will give you -1 and it will be a negative value. Okay. So this is another case you should know. Important hai ye. Okay. And the unit SI unit of work is, you can it's force and displacement product, so it's Newton meter or joule also. All joule, we can write it joule also. Okay. So basically the SI unit, if we see the SI unit of work and energy is same. Okay, it's a form of energy also. So SI on dimensionally it is same. Okay, energy unit is also joule. So basically energy is the ability to do work, or we can say it's an ability to do a certain work. Energy is a form of work, we can say ability to do work. Now so there are basically two form of energy which is quite common with your syllabus, which is kinetic energy and potential energy. So kinetic energy is basically the energy possessed by a body when it is moving with certain velocity. If we see a like example, like car is moving, there's a car. We say the car is moving in this direction with some velocity v. Okay. So we can say the energy possessed by this car is will be defined like half mv square. Okay. Basically, this is the energy possessed by the body when it is moving in a particular direction. Okay. Where m is the mass of the body. This is the mass of the body. And v is the final velocity, we can say. Okay. We can have the derivation of this. Okay. We can derive this by using the concept of work. Like if the body is moving in a particular direction, so by that we can derive that with the help of kinematic equation. Okay. But in the generally the derivation doesn't come in exam. That's just for your concept building. We can derive the derivation also, but you should know the formula. The formula is very important because in application you need to apply the formula, and the you need to merge the two formulas also to get the desired result. Okay. So it's very important to use the concept. Okay. So let's take an example or one question based on the kinetic energy problem. So let's a question like if a body having mass m having kinetic energy k, okay, and velocity v, okay. Now the velocity is doubled, okay. So how much, how much percent, how much percent the kinetic energy will increase is the question, okay. This is based on the kinetic energy concept. So you basically in this question you should know the formula. Basically the formula is kinetic energy is half mv square, okay. This is the formula. Now it's saying that if velocity is doubled, that means suppose if earlier the velocity was v, okay, so now v dash is the basically the new velocity. This is the new velocity. You can also write at v2 also, v1 and v2 also, it's up to you, okay. I'm taking v dash, okay. So v dash is basically twice of v, okay, according to the question. Because earlier the initial value of final velocity was v, mass was initial m, mass is constant, it can't be changed. So velocity is double basically, okay. So velocity is twice of earlier, so v dash is 2v. So the new kinetic energy will be k dash, which is half mv dash square, or half m v dash is basically 2v, so 2v square. So it will come like half m 4v square, okay. So we can take 4 as a common. I'm just rubbing it, so we can write here. Now I'm writing the rest of the solution here. So basically k dash will be half, 4 is taking common, like 4 I'm taking common, so it will be half mv square, okay. So k dash is basically 4 times of earlier k. So earlier kinetic energy was k, now it's 4k. K dash is basically new kinetic energy. But in question, it is asking for how much increase in its energy. So this is new kinetic energy. It's new kinetic energy. So basically, we have to find the change percentage now. So basically, what will you do? K dash minus k. So now kinetic energy is 4k. Earlier it was k. So it's come out to be 3k. So the energy is increased by 3k. Or we can say 3k by, in terms of percentage, we will divide it by initial value k into 100. So you will get the percentage, desired percentage, which will be 300%. Okay. So we can say it is increased by 300%. So you need to understand the difference between increase by and increase to. If it is if in question, it will ask you if the kinetic energy increased to how much percent, then you will say 400%, because you will, in that case, you will have to use 4k value, because it is going with k to 4k. So basically 4 times increase. Na? But in this question, it is asking by how much percentage it is increased, by how much. So you will, in this case, you will have to find the difference. Like earlier it was k and now it's 4k. Now how much increase? So that difference will come in the picture. Okay, so you need to understand these uh, terminology in English language. So language sometimes creates confusion, and rest is your concept formula, and percentage is basically initial value you will have to put there. Okay, so that was the concept. Okay, so it's up to, so thank you for the lecture.